Welcome to ClickMyProject.com. Let me discuss about the process performance of linear receivers in frequency-selective MIMO channels. Let me discuss about the abstract of the project. Orthogonal frequency division multiplexing is a method of encoding digital data on multiple carrier frequencies. Orthogonal frequency division multiplexing is a method of digital modulation in which a signal is split into several narrowband channels and different frequencies. Here, low complexity fast OFDM scheme proposed, which enabled efficient single tap equalization for generic linear channels. The proposed technique is simpler and avoids net data rate loss compared with the existing approach. The complexity and performance of SCFDE system is comparable to that of OFDM, while avoiding the above mentioned drawbacks associated with multi-carrier implementation. On the other hand, FDE does not represent an optimal solution to signal detection over ISI channels, and SC systems cannot certainly offer the same flexibility as OFDM in the management of bandwidth and energy resources, both in single users and in multi-user communication. A major design challenges for high-speed broadband application is the time dispersive nature of the terrestrial radio channels. The effects of multipath propagation can be analyzed in the time domain or in the frequency domain. In the TD, we note that when the channel is larger than one symbol rate, the interference among consecutive transmitted symbols known as ISI distorts the received signal. In the FD, if the communication bandwidth is larger than the so-called coherence bandwidth of the channel, then distinct frequency components of the transmitted signal will undergo different attenuation, resulting in a distortion. Let me discuss about the flow diagram for our process. Initially, the system model has been designed. OFDM systems have some advantages for mobile wireless transmission, as signals are robust against frequency selective fading. For digital signal processing application, OFDM system has become inexpensive and available in consumer products. The intrinsic design of an OFDM system prevents interference among the carriers, also called subcarriers. Inserting a cyclic prefix before transmission can be avoided. Intersymbol interference. This OFDM contrast to ability to select channel selectivity both in frequency and time. Here, IDCT block are used. This is the inverse discrete cosine transform, and the zero padding has been added into our OFDM signal. Next, the parallel signal is converted into serial form. Finally, the digital formation signal is converted into analog formation and passed into the channel. In the receiver side, analog signal is converted into digital and passed into the serial to parallel converter block. Next, here DFT transformation is applied. In the equalizer step, ZF, MMSC and LR aided ZF equalizer are used. Zero forcing equalizer. Zero forcing equalizer refers to a form of linear equalization algorithm used in communication system which applies the inverse of the frequency response of the channel. This form of equalizer was first proposed by Robert Lucky. Zero forcing equalizer applies the inverse of the channel frequency response to received signal to restore the signal after the channel. Next, in the minimum mean square error block and signal the estimator is an estimation method which minimizes the mean square error, which is a common measure of the estimated quality of the fitted values of the dependent variable. In the Bayesian setting, the term MMSC more specifically refers to estimation with quadratic cost function. Next, in the LR aided equalizer. LR aided means lattice reduction aided zero forcing equalizer. The ideal lattice reduction aided equalization for MIMO channel is to combine methods known from lattice theory, in particular lattice reduction, that is the generation of a more suited representation of a lattice with traditional low complexity detectors, in particular simple linear equalization. Next, the performance has been analyzed. The system have some advantages for mobile wireless communication as signals are robust against frequency selective fading. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, write the file and run for executing this process. Here we obtain the result for linear equalizer. Based on the linear equalizer, we can compare the equalizer with available existing methods. Here OFDM blocks are generated. After implementing the OFDM block, we include the equalizer with the receiver side. Then we compare the result. Now we obtain the result. This is the outage probability of MMSC receiver when 2-tap channel and R is equal to 4. These are the parameters initialization. By varying the SNR value, we obtain the outage probability. And this is the input data signal, and this is the encoded input data. This is the DMUX symbol mapper. This is the zero padded result, adding the zero pattern in the input side. And this is the input data signal. This is the encoded input data for MMS equalizer, and this is the DMUX symbol mapper. This is the zero pattern result, and this is the outage probability for MMS receiver when 2-tap channel are used. Various values of R and by varying the SNR values. This is the outage probability of ZF receiver when 2-tap channel and by varying the SNR value and also users. And this is the outage probability for LR aided ZF receiver for 2-tap channel and fixed R value and by varying the users values. Finally, we analyze the performance and compare the equalizer result. Thank you.